And a year ago, we found a sample, and it was, again, we're exploring in places where there were rivers and where there were lakes, and much as on Earth, we think that that's where we'd see signs of ancient life on Mars. And so a year ago, we thought we found what we believe to be signs of microbial life on the Mars surface. And so we put it out to our scientific friends to pressure test it, to analyze it, and go, did we get this right? Do we think this is signs of ancient life on Mars? And after a year of review, they've come back and they said, listen, we can't find another explanation. So this very well could be the clearest sign of life that we've ever found on Mars.
And today, we are really showing you how we are kind of one step closer to answering humanity's one of their most profound questions, and that is, are we truly alone in the universe? So last July, as Secretary Duffy eloquently described, NASA's Perseverance rover found a leopard-spotted rock at Mars. And scientists immediately knew, it was interesting, we hadn't seen anything like that before on Mars. And we talked about it last summer. The moment we found it, we put out the images for everybody to see and everybody to share in the joy of NASA science. So they've done the analysis on these leopard spots, and we think they are potentially made by some sort of ancient life.
These textural features told us that something really interesting had happened in these rocks. Some set of chemical reactions occurred at the time they were being deposited. And so we really wanted to understand what those reactions might have been. This sort of combination of mud and organic matter that has reacted to produce these minerals and these textures is that when we see features like this in sediment on Earth, these minerals are often the byproduct of microbial metabolisms that are consuming organic matter and making these minerals as a result of those reactions. But there are non-biological ways to make these features that we cannot completely rule out on the basis of the data that we collected with our rover payload. So what we need to do from here is to continue to do additional research in laboratory settings here on Earth, and ultimately bring the sample that we collected from this rock back home to Earth so that we can make the final determination for what process actually gave rise to these fantastic textures.
I want to remind everyone that what we're describing here is a potential biosignature. That is a characteristic, element, molecule, substance, or feature that might have a biological origin but requires more data or further study before reaching a conclusion about the presence or absence of life.